So, good evening, everyone. Uh, Welcome to live classes. Today, we are going to discuss mathematics for Cbse class 12. Class 12. And again, I'm going to come up with a very tough topic for students. That's integration. Integration. In this video, I'm going to discuss the following points. One, what is the meaning of integration? Integration with application. Second, I'm going to show you some representation. Which are important to understand the different kinds of integrations that we are going to deal with. Third, I'm going to show you some basic formulae. Fourth, I'm going to show you some problems. And lastly, I'm going to conclude. Now, most of the times, students generally ask, what is integration? Why do we use integration? Why do we use integration? What's the importance of integration? Now, if I tell you that I have a rectangle whose length is L and breadth is B, I ask you, what is the area of this rectangle? You're going to tell me its length into breadth, right? Now, all this formula for area is derived using integration. Integrations are mainly used for calculating areas, volumes, etc. for irregular and regular shaped objects. Irregular and regularly shaped objects. Shaped objects. Now, if you ask me what is the area of rectangle, I'm able to tell you that's length into breadth. But if I give you a very irregular shaped object, which is neither a square, nor a circle, nor a rectangle, nor a triangle, if I ask you what is the area, and if it's three-dimensional, then what is the volume? How are we going to calculate this? We are going to use integration. The application of integration is to find areas and volumes of irregular and regularly shaped objects. The question is, how do we represent integration in mathematics or such a science? We basically use an elongated x, s. The s denotes integration. And we normally use a variable with respect to a function with which we are going to integrate. Now, most of the times, integration is a reverse process of differentiation. So, for example, if I ask you, what is integral, what is d by dx of cos x? d by dx of sin x, for example, the differentiation of sin x. Then you may come and say it's cos x. Similarly, if I ask you what is integral cos x, then it's nothing but sin x. The difference is in integration we add plus c. The question is, why do we add the c? What is the meaning of the c? Now c represents a constant. For example, we're going to discuss why do we add c, which I've done here. So let me give you an example. If I ask you what is d by dx of sin x plus 10. So it's simple. You're going to segregate the functions. You just say d by dx of sin x plus d by dx of 10. Now d by dx of sin x is cos x and 10 is 0. So our answer is cos x. But now if I ask you what is integration of cos x in this case, of course you know that it's sin x, but we are missing out this 10. So this 10 is accommodated as a constant and we write a c. Hope I'm clear with that. So why do we add a constant? We add a constant because there may be a value associated with that function, right, in a given problem. That's why we represent it in terms of a constant c. Now let's do some basic problems. But before we go on to basic problems, let me introduce you to some formula. Some list of formula. So let's start with the basic. Integral x power n dx is equal to x power n plus 1 by n plus 1 plus integral e power x dx is equal to 1 by a e power x plus c. Integral 1 by x dx a by x dx is equal to a into log x plus c. Let us discuss problems based on these three formulas first. Let's go through these three formulae. An important note, integral 1 dx is always equal to x plus c. It's always a constant. Integral 1 dx is x plus c. Similarly, integral 2 dx, let's bring the 2 outside, the 2x plus c. 3 dx would be 3x plus c and so on. Now, most of the times we are dealing with many algebraic functions, and one such function is a power x dx, which is nothing but a power x by log a plus c. So if you're perfect with this phi formula, you will be able to integrate the exponential, algebraic, and logarithmic functions altogether. Now let me demonstrate this to you with the help of a problem. You might recollect in my previous video in differentiation, I have shown you that if we have a function, let us say f of x is equal to e power x, then the differentiation of this would be e power x into d by dx of ax, which is a into e power x. Whereas on the contrary side, if I give you a function e power x in integration, then the integral of f of x is nothing but e power x into 1 by d by dx of x. So this leaves us with 1 by a e power x. Now, if you see in differentiation, we are multiplying, and in integration, we are dividing. Now, that's a very important difference between integration and differentiation. Now, today we are going to deal with indefinite integrals, and I'm going to explain this in more details in upcoming videos as to what is indefinite and what is definite integral. But let us solve some problems based on the 5 formulae that we have discussed in our problems. So let me solve the first problem. Integral for x power 5 dx. Integral 4 into x power 5 dx. Now we know very well the formula of integral x power n dx is nothing but x power n plus 1 by n plus 1 plus c. Now in place of n, we have 5. So n is equal to 5. We have 4, which is a constant. We can bring it outside and we can write this as 4 integral x power 5 dx. Now n is equal to 5. I'm going to substitute in the formula 4 into x power 5 plus 1 divided by 5 plus 1 plus 6. This is going to give me 4 over 6 x power 6. 2 2s are 2 3s are. This is 2 by 3 x power 6 plus 6. So this is how we solve a very simple problem using the first formula of integration that we have learned. Now let's go to the second problem. Let's solve the second problem. Integral 3 power x plus 2. Now I know the formula that integral a power x dx is equal to a power x by log a plus c. Right? A power x divided by log a plus c. If you see, I can use the identity a power m plus n is equal to a power m into a power n, and I can rewrite this function as 3 power x into 3 power 2. And basis are same, I can add up the powers and get back the same function. Now 3 power 2 is a number which is 9. Bring it outside. 9 integral 3 power x dx. Now, in place of a, I have got 3, and in place of x, I have got x. So a is basically 3. So let's use the formula now. So integral 9 into 3 power x dx is equal to 9 into 3 power x divided by log 3 plus 6. Now this is how we solve the problems using the second identity, that is a power x dx. Now what if I have a problem which goes like this? If I give you a problem, integral x square plus 5x x cube, so let's make this as x cube plus 5x square minus 4 plus 7 by x plus 2 by root x whole dx. What if I have such a problem? How do I solve this? Very easy. We are going to take these functions separately and integrate them. Step 1, x cube dx plus integral 5 square dx minus integral 4 dx plus integral 7 by x dx plus integral 2 by root x. Now x cubed dx is as good as x power n. We know the formula, x power n plus 1 by n plus 1, x power 4 by 4 plus 5 is a constant, x cubed by 3. Again, x power n plus 1 by n plus 1. 4 is a constant, that's going to be simply 4d plus 7. 1 by x dx is log x plus 2 by root x. Now, 2 by root x, I can also write this as x power minus half, right? So it's nothing but plus 2 into x power minus half plus 1 by minus half plus 1. And in the end, we are going to write plus 6. So let's simplify this. If there are any terms that we could simplify, it's x power 4 by 4 plus 5x cubed by 3 minus 4x plus 7 log x plus this becomes half. 2 into x to the power half is root x, and that's 1 by 2 again, so 2 goes up. I can write this as 4 root 2, 4 into root x plus 6. So this should be your final answer. Now, if you see, we have just solved a very huge function using integration. We have just considered separate entities. The terms are separated and then we have integrated them. So there is no rocket science here. It's a simple way to solve. But then if you have a problem like this, x cubed plus 5x squared plus 4x plus 1 divided by x dx. How do I solve it? Well, I would give you a minute to, think about it before I really write the solution. Well, you might have guessed the solution. We are again going to separate this entities terms. So x cubed by x dx plus integral 5x squared by x dx plus integral 4x by x dx plus integral 1 by x dx. Now I can simplify. This is x squared. This becomes x. X and x gets cancelled. Now I have integral x squared, which is x cubed by 3 plus 5x squared by 2 plus 4x plus integral 1 by x is log x plus c. I hope you got the idea of solving such equations. As part of exercise, I would like you to solve this two problems, that is integral 1 minus x into root x dx and integral root x plus 1 by root x whole square dx. Solve these problems and post your solutions in the comments. If you have any doubt, question, you can also ask me in the comment section below. Subscribe to my channel and get the latest updated videos online. Just to summarize what we have learned today, we have seen the meaning of integration. What is an integral? So integration is normally used in finding out areas and volumes for regular and irregularly shaped objects. How do we represent an integration? A function which has to undergo integration by an elongated s. Integration is the reverse of differentiation. I give you an example here. Differentiation of sine x is cos x, whereas integration of cos x is sin x plus c. The question is, why do we add c? And here is an example of that where I'm explaining the importance of C. We have seen 5 formulae and we have seen problems based on this 5 formulae. I hope you have liked the session. Please do uh, add your solutions in the comment section. If you have any questions, please do post there. Thank you.